Hello, my name is Ashok Midha. I will be the instructor for ME 6704, Mechanics of Machinery. It's offered every year during the fall semester. This course is a follow-up on what you've customarily known as kinematics and dynamics of machines. This is at an advanced level, and we cover certain advanced topics, and I will go through the details of the course in the next few minutes. So, some details. The staff, that's me, and phone numbers, fax numbers, email, etc. Office hours, typically by availability and or appointment. So nothing that we can't do by email, set up times to meet, etc. The course objectives are largely divided into these two segments, and selected topics in machine analysis and design for high performance and high-speed mechanisms, high-speed applications. The emphasis will always be on what makes the machine or mechanism more advantageous, more efficient, to be able to sustain high performance. So the design will always be geared toward that end. The second segment, the second half of the emphasis in this class would be on the design implications of these mechanisms containing elastically deformable elements. And they can come in two different stages. One is static designs, compliant mechanisms, and I'll get into it a little bit more, and high-speed mechanisms, vibrations and high-speed mechanisms, and I expect to touch on that in this course as well. Here's the textbook we'll be using, Kinematics and Dynamics of Planar Machinery by Burton Paul, and I have that book in my hand. It's a vintage text in some ways. It's 1979 publication, but the book remains ever so green even today. The author has passed away, Burton Paul, but the textbook has a treasure of some very invaluable things expressed most generically and with very high classical mechanics philosophy. So I have always had a preference for this textbook. By the way, this textbook is available online if you wish to search for it for literally giveaway prices. They're very, very reasonable. So I wouldn't mind recommending this to you as a mandated textbook for this class. There are other references I will talk more about, but I do hand out supplementary handouts, which quite a few in number, which help facilitate our teaching and learning functions. And the references, I will mention a couple of textbooks in the class that we would use as reference books for information required in the course. Brief course description, rigid body kinematics, dynamics, and synthesis of mechanisms. Again, that clause here, high performance mechanisms, emphasized. Cam follower mechanisms, and we will go through that, discussing where the benefits of cam follower mechanisms lie or cons that lie relative to the rigid body mechanisms. Review of compliant mechanisms. I will have a few case studies here on compliant mechanisms to show you exactly what they are. And how do we model them? We use a methodology that's been termed pseudo-rigid body model. And we will touch on advanced topics only. And in this case, something like mechanical advantage of these mechanisms. And I'll again show you a few case studies toward the end of this presentation. Transient and steady state vibration response in mechanism systems due to the elastic nature of certain elements. Under high loads, they deform, and the instabilities they produce, referred to here as parametric instability, and their general nature. The grading policy, very straightforward. Homework will be assigned 20%, weekly or biweekly assignments. There'll be projects. I expect 2 projects or 3, which will amount to 30% of the total grade. Computer usage would be emphasized. I think just about every project would require usage of computers, but I have known in the past that the students are adequately prepared in this area and wouldn't need to be a problem. Exams, there are 2, midterm take-home exam and a final take-home final exam as well, each comprising 25% of the total grade. Prerequisites are vector and matrix analysis, planar kinematic and dynamic analysis of mechanisms, interest in kinematic synthesis of mechanisms. After all, we will be looking at these things with ultimately synthesis of mechanisms in mind for high-performance design applications. One of the prerequisites stated, since this is an advanced level class, 6,000 level class, a prerequisite is a 5,000 level class, compliant mechanism design, or consent of instructor. And in a moment, I'll show you what the prerequisites for the compliant mechanism design class is, so that you are assured that you may well be prepared for this class as well. And ability to handle computer projects assignments, of course, I mentioned that. But here are the prerequisites for the compliant mechanism design class, which is a prerequisite for this one. And it's very similar sounding content. Vector and matrix analysis, planar kinematic analysis of mechanisms. This is the undergraduate course that you've had in one form or another. Strength of materials, that's compliant mechanism design. I don't believe we need that for this one. Linear deformation and stresses and beams. Ability to handle computer project assignments. Because of the complexity of some of these things, you just about have to rely on numerical methods to solve these problems. Interest in kinematic synthesis of mechanisms. So you see, looking at this, you may well be prepared for this advanced level class, ME 6704, Mechanics of Machinery. Some of the topics we'll cover may go back to kinematics of 4-bar mechanisms. There's a generic 4-bar mechanism to the left, crank rocker, and to the right is a very small crank rocker mechanism on the right, geared for high-speed applications. And we will discuss the mechanisms, the class of mechanisms relying upon small cranks and how they are made so efficient because of that in terms of mechanical advantage, torque gain, power requirements of the motor, vibrational instability, etc., etc. So the whole thing will rely on the entire philosophy and the design of mechanisms using small cranks. And we'll look at analytical expressions that would help us synthesize these mechanisms for required needs. Here's a geared 5-bar based 7-bar slider mechanism. We will look at synthesis approaches to design such mechanisms which produce complex functions, displacement time diagrams like a dwell mechanism with very smooth variations, so much so that they are perfectly suitable for high-speed applications as opposed to anything else that one might think of. So we will cover those methods. Here's an example of a compliant mechanism which has had issues, very difficult to design for high mechanical advantage. I mentioned I'd bring in a case study of the compliant mechanisms, and here are a few of them. Very elusive to predict the performance of such mechanisms, whereas all designers thought that as you squeeze these handles, that the crimping action up top would have increasingly high mechanical advantage, which turns out not to be the case in this particular configuration. So it's taken a while for us to figure out, and now we know exactly why these things behave as they do and how we might design such mechanisms for high mechanical advantage. So we actually have analytical characterization of mechanical advantage of compliant mechanisms, which we will also cover in this class as a special topic. This is a gripping mechanism that retains its fingers in a parallel motion function, near parallel grasp. Here's a fishhook remover, one-piece, fully compliant fishhook remover that does its function with a certain mechanical advantage designed in, as well as other functions like ergonomics and rust-proof and corrosion-proof and floating in water, etc. So, and I think with that, let me just kind of wind down on this introduction. Here's a very similar configuration used for a chip carrier extractor from motherboards, compliant in nature. Another poor man's compliant hand attached to the stump, the arm, amputated arm of an individual, providing a certain amount of mobility for use in everyday functions. Let me just close shop here. Again, the course should be a very pragmatic, useful discourse on the design of high-speed machinery, high-performance machinery, high mechanical advantage, mechanisms and machines, and those built with compliant material, compliant mechanisms with a whole list of some great advantages in the process. So that wraps it up for me for Mechanics of Machinery, ME 6704. Maybe we'll see you in class. Thank you.